Hello, this is Mr. McLaughlin, and we are back with another e-learning activity, Algebra 2, College Prep. This is Chapter 11, Data Analysis and Statistics. And today we're covering Section 11.1b, the graphical representation of data. We are going to start off with 4 good SAT questions. So if you could hit the pause button and try all 4 of these, and come back when you're finished, we'll talk about the answers. In the first problem, in the upper left-hand corner, we're asked to find the result of the division of 2 polynomials. If I take the first polynomial, which is f of x, and I put that in my numerator, x to the third minus 9x, and I take the second polynomial that was given to us, which is our g of x, and I put that in the denominator, we would have set up our nice rational function here. In the land of rationals, we always like to use factoring as a tool to make the problem easier. So on the top here, if you take a look at it, we got a GCF, which then I believe will be followed with the dots. And the bottom over here, we got a mapping problem. So hopefully you factor the top by pulling out the x first. And that would leave you with x squared minus 9 left over, which if I finish my numerator and factoring at the dots, plus 3 times x minus 3. And then in my denominator there, that's a mapping problem. Multiplies to be -3, add to be -2. It's got to be x minus a 3 times an x plus 1, which if I take a close look at my rational function now, and hopefully remember, anything that is exactly the same on top and bottom can cancel out. The x minus 3s would cancel out. If those canceled out, we would have an x times an x plus 3 on top with an x plus 1 on the bottom. And that one there should be answer D. All right, we go to the next one. It is giving you the equation of a circle. And the question is to connect the diameter of the circle to one of the endpoints of the diameter. So first thing would be to just kind of get a little of a graphic representation here. If you remember anything about circles, we're given 2 things from their equation, their center and their radius. So the radius squared is 16, which means our radius is 4. And the center comes from the 6 and the 5. But remember about your sign rule, the 6 here is positive because it has a negative sign in front of it. And then the 5 is the opposite, which would be -5. So if you want, you plotted the point 6, -5. And a good sketch, not to be too crazy here with your accuracy, but if I plotted that point 6, -5 and said that's the center of my circle, and then I noticed something about the radius being 4, well then that would get me right to that point 10, -5. So 4 units to the right of the center, 2, 3, 4, would be that point right there, which is 10, -5. And then the center of the circle was given to us as 6, -5. So if we wanted to find the endpoint that represents point Q, it would be on the left side of the center, 4 units away. So if we said 4 units away from the digit 6, that would put us back at 2, -5. And that would represent point Q. Over here is point P. And if we could sketch a decent looking circle here as best I can. My circle coming out. And then that diameter of the circle has got to connect those 2 points. And hopefully, without a doubt, that looks like a pretty good diameter there. Question, where is point Q? I believe point Q is at letter A there, 2, -5. Bottom left-hand corner, we have 202 people going on a camping trip. They brought 60 tents of them. some of the tents are for 2 people and some of the other tents are for 4 people. Assuming all the tents were filled to capacity and every person got to sleep in a tent, exactly how many of the tents were 2-person tents? So what I did in this one is, all right, let x equal to the 2 people tents. Let y be equal to the 4-person tents. And by using x and y in this example, we can set up a nice looking system here. So first things first, if we got 60 tents, then that means the 2 people tents and the 4 people tents, the x plus y must make a total of 60 tents. And every time we bring an x, it can hold 2 people. And every time we bring a y, it could hold 4 people. And altogether, it held 202. So that would be our system. The question again is to find out how many of the tents were going to hold 2 people. So that's my x, so I got to eliminate my y. If I take the top equation and multiply it by -4, that will remove my y from that system, which would then leave me with an x-only equation. Try to make that centered there for you. There we go. All right, so -4 times the x is -4x. -4 times the y is -4y. And -4 times the 60 is -240. And if we add these 2 equations together now, the y's will cancel out like we wanted them to. The 2x plus the -4x equals a -2x. The 202 minus that 240, that's going to turn out to be a -38. And we divided that out by -2, your x value will be 19. So answer would be that we had 19 2-person tents. Last one over here goes back to graphing analysis. And if you check it out, we have a 0 there at -3. We got a double 0 there at 0. Kind of call that the classic bouncer, where it hits the axis and turns around on you. And then another 0 at 2. So if you remember the formula for it, if a 0 is 0, then that would just be x minus 0 being squared, which could be simplified as x squared. If -3 is a 0, that would be x minus -3, which come out to be x plus 3. Got those 2 taken care of. And then, of course, this last 0 is at 2, so that would just be x minus a 2. So we could say that our function that represents the curve that has been graphed could have an equation that resembles x squared times x plus 3 times x minus 2, which of course that would be answer B there. All right, why don't you guys flip over the page there and we'll start talking about section 11.1b. Everything in this section is just going to give you data displayed in either tables or charts or bar graphs or pie graphs or line plots. So just a matter of you really being able to read data represented in a bunch of different forms. So we'll go right to example 1 here. Example 1 is talking about some neighborhoods. And it simply said, if a couple neighborhoods were asked if they would like to have a shopping center nearby, their following sample space, their data that they collected, could be represented here in the charts. So first question says, what percent of the people responded yes? Well, first of all, we were asking 225 people. So as always, our total sample space is 225 individuals. And the question says, how many of them answered yes? And of course, that would be 79. So 79 of 225, and asking for a percent. So again, if you could round it off to maybe 1 decimal place, somewhere around 35.1% for that one. If we go to the second question, what percent of the people from the Pines were undecided? So again, first thing we'd say is, well, we asked 225 people, And now which people were undecided that came from the Pines? That again would go back to just the simple 19 people from the Pines were undecided of a total 225, and that would be rounded off to about 8.4%. And then finally there for part C, what's the probability that a person selected at random said yes and was from Highgate? So again, random person selected out of our sample space of 225. They had to be from, of course, Highgate, and they had to say yes. So our yes people from Highgate was at 43. And again, if you go to one decimal place there, roughly about 19%. So that's just using data from a table, a sample space of individuals to calculate nice simple percents. Example 2 is a bar graph. Take a look at that one for a second. The goal is to be able to interpret and analyze data that is on a bar graph. So if you read the fine print down here, they're just taking a look at 5 different types of energy sources: biofuels, geothermal, hydroelectric, wind, and wood. And you got a nice little slew of questions that are about those and how you can analytically look at the graph and make some decisions about what's happening. So in question A, it says, which of the energy sources grew? So very simple connection with growing. They have to go up. So that one's obviously going up. That one's going up a smidge. That one's going down. That one's going up quite a bit. And that one's going down. So these guys crossing out are definitely not going up. None of those grew. So we say the biofuels grew. The geothermals grew. And of course, finally, wind power grew. Nice little analyzing of a bar graph. Question B says, hydroelectric energy consumption decreased. By how much do you think it decreased? So you go to your hydroelectric and you say, all right, what's going on there for that decrease? Well, that bar graph there is at about 2.75. And then it decreased down to 2.5. So of course, decreasing is a subtraction quantity. Subtract the greater value, which represents what happened in the year 2000 compared to the lesser value in 2010, and that would be a decrease of about 0.25 quadrillion BTUs. Again, these are all measured in quadrillion, quite a number there. Go to part C. Wood energy consumption also decreased, and what was the percent of decrease? So if we take a look at the wood decreasing, first thing we'd say is let's get our eyeballs pinned on the wood concept. And if we look, of course, at the wood concept, we'd say there's our bar graph that's representing wood. And when we talk about the percent of decrease, we always say how much did it change divided by the original. So the original amount is right there. That'd be 2.25. The amount that it changed, it went from 2.25 down to 2. So that change is by 0.25. And if we said, all right, percent of change is the amount of change divided by the original amount. And of course, you throw that into your calculator. The 0.25 divided by the 2.25 is about 11.1%. Wood consumption for energy decreased by 11.1% over that 10-year span. And last one, of course, going back to probability. Just got done with that chapter. Probability, of course, is success over total. What's the probability that you choose one of the 5 energy sources and the consumption decreased? So first of all, we are looking at a bar graph that talks about 5 different types of energy sources. And as we know, 3 of them increased and 2 of them decreased. That'd be 2 out of 5. Of course, that would be exactly 40%. All right, flip the page there. We're going to our third way to analyze data, and that is by using a circle graph here. So hopefully your circle graph is looking pretty good. The graph represents 300 students at HF. How many of the students are considered bus riders, car riders, or fall into the category of walkers and bikers? So this is just taking a total amount of students and categorizing each one of them. So we got 3,000 students at HF, roughly about 3,000. And they're telling us, of course, that about 20% were riding the bus. So if we take that 300 and we multiply that by 0.20, 20%, we got about 600 kids taking the bus. If we go to our car riders, it's 45% of those students. So again, 3,000 students at HF, and about 45% of them are taking a car to get to school. So a lot more students are car riders, about 1,350 based upon this data. And then finally, of course, we're talking about our walkers over here, or our bike riders, our kids that are not getting a ride on a bus or a car. So our walkers and our bikers are about 35%. So again, we got about 3,000 kids, 35% fall into the walker and biking category. That's 1,050. Again, if all our numbers are right, when you add up the categories of the bus riders, the car riders, and the walkers, that should equal to those 3,000 kids. Double check that math there really quick on your calculator. That is adding up correctly. And if we were going to make a drawing and we wanted to graph it accurately, what would the measures of each of these angles be for the car riders, the bus riders, and the walkers? So first thing we like to say in a circle, we have 360 degrees. So again, our car riders are representing 45% of that. So car riders would just be 0.45 of the 360 degrees in a circle, which would have an angle, central angle, of course, about 162 degrees. Our bus riders, on the other hand, are making 20% of that circle, so 20% of the 360, which would be roughly about a 72-degree angle. And then, of course, that final central angle there, the walkers and the bikers, those guys are making a 35% chunk of that circle, where that circle, of course, measures 360 degrees. So again, multiply that on your calculator. That central angle will be about 126 degrees. And then if you add them all up again, they should total 360. All right, one of our last ways here that we will be talking about analyzing data, and hopefully you've all seen line graphs before, line plot, plotting data on a line. This one is checking out what is going on with respect to the amount of water that we have in cases based upon a time component. So the goal is to be able to interpret and analyze the data that's on the line graph. And we simply say, what do you think that this graph could represent? What's a good scenario that would apply to the graph, where if you look at it, we're starting off at time of 0 with 20 cases of water. And by the time we, of course, get over here to the 4-hour mark, we have less than 10 cases of water. So, you know, a good discussion might be, maybe this is a football game. And the concession stand starts out with 20 cases when the game starts, and by the time there's sold a lot of water. So we can definitely say this is a descending trend. We are selling water with respect to the time component there. And now we have a couple questions about that, right? After 3 hours, how many cases of water are left to sell? So again, we got 20 cases of water. If we go to the 3-hour mark, you can see that we sold 10 cases of water. How many cases of water are left to sell? Well, hopefully, of course, if we had 20 and we sold 10, we still have to sell 10 more. Part C, on what time interval are the cases decreasing the fastest? So we say, all right, if we look at our graph, where do we see like the biggest drop in a time period, which is broken down to half hours? And of course, that would probably be the steepest one right there. On what time interval are the cases decreasing the fastest? From the 2-hour mark to the 2.5-hour mark. Why do you think that's happening? People must have been very, very thirsty right here. Maybe if we're talking about it being a football game, maybe that was like halftime of the football game where we had a nice intermission and people went to go buy some snacks and bought some water. And the last question, here's a really good one, just about the connection between how much we spend on the water and then how much profit we make on the water. So a case of water costs $5, and we go ahead and we turn around and sell each bottle for $1. So the big question, of course, is how do we figure out the profit on that, right? Well, the profit, of course, is going to be how much money we make compared to how much money we spent. So if we sell 24 bottles for $1 each, that means we would have brought in $24. However, we did already purchase the water for $5 a case. So first statement there would be that every time we sell a case of water, we're making a profit of $19. So first part about answer to section D here says, what's your profit after 1.5 hours? So at the 1.5 hour mark, how many cases did we sell? So once again, you go back up and analyze your bar graph, go to 1.5 hours in, and you can say, well, we sold 5 cases. So 1.5 hours in, 5 cases of water were sold. We made $19 per case. If you take your 5 cases that you sold and you multiply it by the $19, 5 times that 19 should be a profit of $95. Again, 1.5 hours into this event, we sold 5 cases of water, making $19 per case. And then the next portion of the question says, what happened after the 3-hour mark? Okay, so same idea here, guys. Check out what happens at 3 hours. At the 3-hour mark, we sold 10 cases. All right, we had 20, and now we've got 10 left. So nice little connection. After 3 hours, we sold 10 cases. And again, what do we know? Every time we sell a case, we get $19 in profit. 10 times that 19, it's $190 profit. Well, that is all for today's e-learning activity. If you flip the page there in your notes, you'll notice that the homework there is attached for you. It's page 107, 1 through 14. And again, it's just taking a look at some nice data that's been put together in line graphs, bar graphs, circle graphs, and of course a couple little tables there as well. So if you could take a picture of that assignment and please send it to me via email, we will record your points for this e-learning activity. Everyone stay safe, and we'll talk to you soon.